Welcome to this video on how to graph linear inequalities. Linear inequalities are going to have a less than or a greater than sign. Here's an example. Y is greater than or equal to 3x plus 1. When it has an inequality in it, there's going to be a four-step procedure that you're going to want to follow when graphing this inequality. Step number one, you're going to want to make sure to get y by itself. In this problem, we already have y by itself, so we can continue with the next step. Step number two, we need to determine if the line is going to be solid or dotted. When graphing linear inequalities, if you have a less than or equal to or a greater than or equal to sign, then we're going to use a solid line when graphing. Because points on the line will actually be solutions to our inequality. However, if we don't have that equal to, for example, if we just have less than, or we just have greater than, and no equal to, that means we're going to use a dotted line. We'll use a dotted line when graphing, and that's because the points on the line are not actual solutions to the inequality. So for this one here, we have y is greater than or equal to 3x plus 1. Because it's equal to, we're going to be using a solid line. So I'm just going to write you this here so we don't forget. Step number three, we need to graph the line using y equals mx plus b. Remember that b represents the y-intercept and m represents the slope. So here, this plus 1 is our y-intercept, and this 3 is our slope. Because we have the y-intercept and the slope, we can graph it. I'm going to graph the y-intercept. That's going to be at 1. And my slope is 3. So from this y-intercept, I go up 3 over 1. I'm using a solid line, so I'd go ahead and graph this with a solid line. Just like that. In my last step, I need to shade. Because it's an inequality, we have an infinite amount of solutions that could make this statement true. And they'll all be on one side of the line. If it's greater than, we're going to be shading above the line. If it's less than, we'll be shading below the line. Because we have a greater than or equal to sign, greater than means shade above. And so we would shade above the line like this. Our solution would be all points on the line and also above the line. We could even check this by taking a point. For example, let's see, I could take this point right here. This is the point -2, 1. If I took the point -2, 1 and plugged it in, we'll actually find out that this statement would be true. We're going to plug -2 in for x and 1 for y. I would get 1 is greater than or equal to 3 times -2 plus 1. 3 times -2 is -6, and -6 plus 1 is -5. Is 1 greater than or equal to -5? You bet. And so notice all points above the line are a solution to this linear inequality. Okay, let's try one more. 4x plus 2y is less than 8. Let's go through the procedures. Step number one, we need to solve for y. So let's see, I need to get y by itself. I'm going to minus 4x to both sides. When I do that, I get 2y is less than -4x plus 8. I then need to divide everything by 2 because, again, I want to get my y by itself. When I do that, I get y is less than -2x plus 4. Now notice, I didn't flip the sign, and I wrote this in here just in case. If you ever have a problem where you divide by a negative, don't forget you'll have to flip the sign. I divided by a +2, so there's no sign flippage needed. Okay, now I need to determine if it's going to be solid or dotted. I've got y by itself, and I have a less than sign. Ooh, but it's not equal to. So because it's not equal to, I'll be using a dotted line when I graph this line. Step number three, graph the line using y equals mx plus b. So my y equals mx plus b, my b is right here. This is the b, so that's the y-intercept. And this is the m, so this is my slope. So I'm going to graph the y-intercept. That's at 4. 1, 2, 3, 4. There's my y-intercept. And my slope is -2, so I go down 2 over 1. Because my slope is negative, I go down. Okay, now I'm going to graph the line, but it's dotted, so I'm going to use dotted lines to graph. So it's going to look like that. Again, we use a dotted line because points actually on the line are not solutions. Last step, I need to shade up if it's greater than or down if it's less than. I have a less than sign here, and because it's less than, I need to shade below the line. So underneath is where I'm going to be shading. And that's how we graph a linear inequality. Okay, so now it's your turn to see if you understand this concept. Go ahead and pause the video and give these 3 problems a try. When you're ready to check your answer, go ahead and unpause it and we can work on it together. You can pause the video now. Okay, here we go. Let's give it a try. We're going through these 4 procedures to graph y is greater than or equal to 5x minus 1. Step number 1, we need to solve for y. The good news is that this one is already solved. Y is already by itself. So y is greater than or equal to 5x minus 1. So we need to determine if it's going to be solid or dotted. This has an equal to in it. So because of that, we'll be using a solid line. Now we need to graph using y equals mx plus b. So this is the b, this is my y-intercept, and the value with the x is the slope. So I'll graph my y-intercept at -1, that's right here, and my slope is 5, so I go up 5, 1, 2, 3, 4, 5, over 1. I'm using a solid line, so I'll connect these with a solid line. Oh, it's not very straight, but you get the idea. And then I need to decide which direction to shade. It's greater than, so I'm going to shade above the line. So above the line is where I shade. And that's how you should have graphed that one. Let's try this next one. We have 2y is less than 3x plus 4. I need to solve this for y. Notice that y is not by itself, so I'm going to go ahead and divide everything by 2, both sides by 2. When I do that, I get y is less than 3/2 x plus 2. Is this going to be solid or dotted? It doesn't have an equal to in here, so that means I'm going to be using a dotted line. So now let's graph the line. My y-intercept is plus 2, so that's right here on the y-intercept. And my slope is 3/2. So remember, slope is rise over run. I'm going to rise 3 and run 2. I'm using a dotted line here. To graph this inequality. And because it's less than, we shade down. We shade below the line. And so I'll use, so on this one, we're dotted and below. Okay, last one. Let's give it a try. On this problem, we're going to have to do the 4 procedures again. Step number 1, we want to solve for y. This one's not solved for y, so let's go ahead and get y by itself. I'm going to minus the 4x, so I'm left with -2y is greater than -4x plus 10. So I minus the 4x over to the other side. I now need to divide by -2. Uh-oh. Whenever you divide by negative number, don't forget, you've got to flip your sign. So I'm going to be left with y, and it's not greater than anymore. It's less than 2x minus 5. Okay. Is it going to be solid or dotted? It doesn't have a bar underneath here, so it's not equal to, therefore it's dotted. I'm going to graph by finding my y-intercept, which is -5. That's right here. And my slope is 2. So I'm going to go up 2 over 1. My last step is to connect these with a dotted line. And because it's less than, we're going to shade down underneath. And that's how we do graphing linear inequalities. Thanks for watching and keep working hard.